Now let's look at the generalized power rule. It's very closely related to the chain rule. What it says is if y is equal to a function of u that is raised to a power where u is a differentiable function and n is some rational number, then dy dx is n, because we bring down the n, u to the n minus 1 times du dx. Another way you'll see it is d dx of u to the n is n u to the n minus 1 times u prime. Now, suppose we look at, let's look at what dy dx is. All right, and I need to apply the chain rule here. So this is dy du times du dx. All right, well, dy du is the derivative with respect to u of u to the n times du dx. Well, it doesn't matter whether I call these u's or x's or gammas. It's the same thing. I use the power rule. N u to the n minus 1 times du dx. Now, this is what we found before, but again, we tend to be too lazy, so we'll write the prime there. Now, let's see if we can find the derivative of this. F prime of x is, now let me put the generalized rule up here. The derivative with respect to x of u to the n is n u to the n minus 1 times u prime. And then I'm going to break it up into the 3 sections. All right, the first thing I'm going to do is bring down the n. So this is the n, and so n is 3. And the second thing I'm going to do is u to the n minus 1. So in this case, u is 3x minus 2x squared to the 3 minus 1. So this is the second part. And now I'm going to multiply by the derivative with respect to x of u, or of the n side. So let's see, this is 3 times 3x minus 2x squared times 3 minus 4x. Now, let's find all points of the graph. F of x is a cubed root of x squared minus 1 squared, for which f prime is 0. Or no, f prime equals 0, and for those for which f prime does not exist. Well, let's start by writing this as f of x is equal to x squared minus 1 to the 2/3. Now you can see this is generalized power rule, where n is 2/3 and u is x squared minus 1. Now du dx is 2x. You can also do the problems this way, where you come over here and you list everything out first. So f prime of x is 2/3. I bring down the power, and then I lower the power of the function by 1, and then I take the derivative of the inside, which is 2x. Now I do need to rewrite this as 4x over 3 times x squared minus 1 to the 1/3. Now, we want to know where does f prime equal 0. Well, the only place f prime of x equals 0 is when the numerator is 0. So that is when x equals 0. Now, they ask, where does f prime of x does not exist? Well, that'll be where my denominator is 0. So this is where the denominator is 0. So where does 3x squared minus 1 to the 1/3 equals 0? And we see that's only where x squared equals 1. All right, so ultimately, that's where x equals plus or minus 1. Now, what if we were to differentiate something like this? The first thing you want to do is rewrite it. G of t is negative 7 times 2t minus 3 to the negative 2. So g prime of t, now see we're taking the derivative with respect to t, not x, is negative 7 times, I bring down the power, negative 2, I lower the power by 1, so it's negative 2 minus 1, and I take the derivative of what's inside, and the derivative of what's inside is 2. And now I simplify. 7 times 2 is 14, times 2 is 28, and it's positive. And this is 2t minus 3 to the negative 3. Now, we're not supposed to have negative exponents. Done.